Okay, so today we're going to do lesson 7.2, which is titled Analyzing Arithmetic Sequences and Series. We're going to learn how to identify and write the rules for arithmetic sequences. Let me zoom in here so you can see that a little better. So we're going to learn to identify and write rules for arithmetic sequences. We're also going to find the sums of the finite arithmetic sequence series, and we're going to graph some of these too. Once again, just like in lesson 1, a sequence represents the list, where the series represents the sum of that list. So in an arithmetic sequence, the difference, and this is important, it's the difference in consecutive terms that's going to be constant. So difference. And that difference is, that constant difference is called a common difference. Constant difference, common difference, I'll probably say both of them. So constant difference, common difference, it's basically the letter D is going to be used to represent that common difference. And there are functions that we've already been working with in the past that you've worked with for a long time that do have a common difference, and those are linear functions. So an arithmetic sequence is, you're going to see it's going to relate very much to the linear functions. It is a linear function. So in these first examples, you can see there's a list of numbers, and we're trying to tell whether each sequence is arithmetic or not. And we've done finite sequence or finite differences before, where if you just take the number on the right and subtract right to left, 16 minus 10, and you get 6, and then subtract right to left again, and you see that the differences are not the same. So they do not have a common difference. If we went one more, you would see 5 minus 1 equals 4. So this is not an arithmetic sequence because it's not linear. The first differences are not the same. If we were to go find another common difference, or if I went to find the second difference, it would show that it was quadratic. So this set of numbers here would represent a quadratic function, not a linear or arithmetic function. So arithmetic function is basically a linear function, and it's going to have a common first difference, just like we've seen in the past. So now let's go right to left here. The negative 8 minus a negative 5. Be careful because you're subtracting a negative. That's going to make that positive. So when you're subtracting a negative, that's going to become a positive 5. Negative 8 plus 5, or positive 5. Negative 8 plus 5 is going to be negative 3. Subtract right to left, negative 5 minus a negative 2. Again, it's become plus 2, so negative 5 plus 2 is going to be a negative 3 again. And then when we look at the next set, negative 2 minus 1 now is negative 3, and 1 minus 4. Okay, I need to erase that. 1 minus 4 gives you a negative 3 also. So we have a common difference, and it just happens to be a common first difference, which makes it linear, and it also makes it arithmetic, and that common difference would equal negative 3. So in our formulas that we're going to be seeing later on, D is the variable that we use to represent that common difference, and that common difference is going to be negative 3. All right, so that's number 1, how to identify whether something is an arithmetic function or not. Next step, we're going to learn how to write the rules, and there's going to be a lot of writing equations today, so stay with me. In algebra, I'm not sure what, okay. The nth term of an arithmetic sequence with the first term a sub 1 and a common difference D is given by this equation. So you definitely want to highlight that. That's going to be an important equation that we're going to use a lot. It's also one that I believe we have to memorize. So a sub n, which means the nth term of an arithmetic sequence, can be found by taking the first term, a sub 1, plus n minus 1. Again, the n is the position, so if it's like the 15th term, you would put 15 in here, minus 1, and then times d, which again is your common difference. So in this example, they're saying that the nth term of an arithmetic sequence with a first term of 3, so that 3 is going to be your a sub 1, and a common difference of 2, so 2 is going to be your d, or common difference, is given by this equation. So you can kind of see how it relates. See the a1, now it's 3, so we just plug the 3 in for a1. And then the common difference, d, now is replaced with a 2. One thing we do need to do with arithmetic sequences is, the rules of arithmetic sequence is to simplify them. So even though this is the formula that we plug it into, when it's linear, we can, or an arithmetic sequence, we can simplify it. What do I mean by that? Well, we're going to distribute the common difference, d, or 2, which gives me 3 plus 2n minus 2, and then combine your like terms, the 3 and the negative 2, give us 2n plus 1. So that is our simplified rule. With arithmetic sequences, you do want to simplify the rule so that it's basically looks just like an equation of a line. You've got a slope, you've got a y-intercept. However, when you have an arithmetic sequence, one of the differences between the line and the arithmetic sequence is that your domain has to start with 1. So this is your equation, but n has to be greater than or equal to 1. So you really won't have a y-intercept at 1, but the first term would be your 3, and then you could use your slope from there to graph other points if you'd like. But we'll get to the graphing on the next page. So this was an example of how to write an arithmetic sequence given the first term and the common difference. Well, what if you're just given the list and not given the common difference or the first term? Well, you can figure it out. If you're given the list, the first number in the list is your a sub 1. So we already know a sub 1, and that's part of our formula up here. To find d, you just subtract right to left. So 16 minus 13 is 3. 13 minus 10 is 3. 10 minus 7 is 3. So common difference, d, equals 3. I would recommend that you write down the formula, because the more you write it down, the easier it will be to remember. So a sub n equals a sub 1 plus n minus 1 times d. Now it's just a matter of plugging the values in. So your a sub 1 is 7, your d is 3, and then just fill in the other pieces. And now we're going to simplify this by distributing the 3. So we get 7 plus 3n minus 3. Combine like terms, and you get n, a sub n equals 3n plus 4. So the common difference, or the rate of change, is 3. And if this was a linear function, it would have a y-intercept at 4. However, it's only for n's greater than or equal to 1. Because in arithmetic sequence, the domain starts with 1. All right, so here's another one that you can try. I'm going to turn this projector, I'm going to pause it so that you can try this on your own, and then I will reveal my solution in a couple minutes. So try B on your own. Don't forget to write down the formula to help you remember it. And then once you've plugged the numbers in, make sure that you simplify the equation. Okay, here we go. So hopefully you are getting the same answer that I did. When you subtract right to left, I get a common difference of -7. My first term is 15, so the 15 goes into the equation for a sub 1. Your -7 goes into the equation for d, and then we distribute the -7 to the n minus 1 and combine like terms. The 15 plus the 7 gives you 22. And again, it's only for n's that are greater than or equal to 1. So you do have to state that condition in there, that the number n, whatever your input is, has to be greater than or equal to 1. All right, so that's how you would write an arithmetic sequence given the first few numbers in the set. Okay, the next thing you're going to do is, again, write a rule. So we're writing arithmetic sequences again, but instead of being given the list, you're going to be given a term, and you're going to be given the common difference. So they're telling you it's an arithmetic sequence, so pay attention to that. In the next section, we're going to be doing geometric sequences. So you've got to read the directions to see whether it is an arithmetic sequence or a geometric, which we're going to get to in section 3. So the one term that they're giving you is a sub 12 equals 52, which is basically like a point. It's the input is 12, the output is 52. They're telling you the common difference is d, and they want us to write the rule using, again, the same formula that we've been writing down. A sub n equals a sub 1 plus parentheses n minus 1 times d. The problem here is, though, that we don't know what the first term is. We know what the 12th term is, so we can find the first term by plugging in our a sub 12, which is 52, over here. And then 12 is the input, which we're going to substitute for n, and then 6 is our common difference, which we're going to plug in for d. So let me show you how that works. So your a sub n, which is basically a sub 12, equals 52. We don't know the a sub 1, so we're just going to leave that as a sub 1. But we do know that our n, the input for this term, is 12. So 12 is going to be in place of our n, and the 52 is going to go in the place of a sub n. And then subtract 1, and then your common difference they told you was 6, so we're going to multiply that by 6. Now, because you know what these two numbers are, you do not need to distribute. You can just simplify what's in the parentheses. 12 minus 1 is 11, times your 6 is 66. So then bringing this down, I get 52 equals a sub 1 plus 66, and then subtract to find your a sub 1. So our a sub 1 then is going to equal a -14. Okay, well, what can we do with it now? What, are we done? No, we have to write the rule for the nth term. So we're going to use our formula again. But now, since we know our first term, we can plug that in. But again, I always like to start by rewriting the whole formula. A sub n equals a sub 1 plus parentheses n minus 1 times d. So we're writing a rule for any term now. So we're going to write the rule for the nth term. So the n does not get replaced. It's going to be a sub n equals our a sub 1, which we just found was negative 14, plus n minus 1, our common difference, d, we were given is 6. So now it's just like what we had done in the last couple of problems. Distribute negative 14 plus 6n minus 6, combine like terms, and you get 6n minus 20. And there's our rule. So we just wrote the rule for an arithmetic sequence that had a term, the 12th term was 52, and it had a common difference of 6. Okay, ready to move on to the next page. Moving right along. So this example is basically exactly like the last one. The only difference is we're going to be graphing also. So this is a good one for you to maybe try on your own, to at least write the sequence, kind of like the last example. But the difference is we're going to be graphing the first 6 terms also. So again, I'm going to pause. I'm going to do the first couple of steps, then I'll reveal what I've worked out, and then show you a little bit more. Don't forget to write down the formula. Mistake. Oh, I'm just realizing that it's not pausing on the video. So I guess I'm not going to have to worry about revealing because you're watching me do this. Okay, well, anyway, so let's just do it together. But anyway, I made a mistake here. My common difference is 7, not my n. My n is 11. That's the n value. So in place of n, I'm going to put 11 minus 1. That's part of the formula. And then plug 7 in for the common difference. Simplify. 11 minus 1 will be 10 times your 7 will be 70 plus a1 sub 1 equals 50. Subtract your 70 and we get negative 20 is our new, we just found our a sub 1. So now that you've got your a sub 1, kind of like when you're getting a line, when you're writing the equation of a line, you have to find the slope and a point, or the slope and the y-intercept before you can write the equation. This is very much like it. You have to find the d, or the common difference, and the first term in the sequence. So again, a sub n equals a sub 1 plus n minus 1 times d. And we're writing the rule for a sub n, so we want to bring the n back. So n is now part of our formula, our equation. A sub 1, which we just found, was negative 20. And then n we're bringing back into our equation, but the common difference is going to be what it was before, 7. So that doesn't change. Now, just like before, distribute. Switch pens out. Different color here. So a sub n equals negative 20 plus 7n minus 7. The negative 20 and the negative 7 combine like terms to get 7n minus 27. So that is our rule. The next thing that we're supposed to ask to do is so we found the rule. So 2 things: write a rule for the nth term of the sequence, which we just did, then graph the first 6 terms. So we need to basically make a list of our first 6 terms. Well, we already know what the first one is. That's what we found over here. So 20 is the first term in our sequence. To find the second term, just plug 2 or substitute 2 into the equation for n. So 2 times 7 is 14. 14 minus 27, let me think about that, is negative 13. Wait, negative 20, negative 13. Okay, so sorry, I forgot the negative there. So your first term is negative 20, the second term is negative 13, and we got that by substituting 2 into the equation. Now substitute 3. So 3 times 7 would be 21, minus 7 is going to give us a negative 6. Then plug in 4. 4 times 7 is 28, minus 27 is going to be 1. And then, so 1, 2, 3, 4. So that's your first, second, third, fourth, fifth, and sixth. So we have to find 6 terms. The fifth term, again, plug it in. 5 times 7 is 35. Minus 27 is 8. And then 6 times 7 is 42. Minus 27 is 15. All right, so now that we've got our 6 terms, our first 6 terms, so these are the numbers in our sequence. These are basically your y coordinates, and the 1 through 6 are your x coordinates. So at 1, we have negative 20. At 2, you have negative 13. At 3, you have negative 6. Notice your intervals are going by 5s. But the intervals here are going by 1s. The fourth input was 1, or the output was 1. When we plugged in 5, we got 8. When you substituted 6, you got 15. So here is our arithmetic sequence. And it is not something that we connect. You do not connect the points. It is not a continuous function like a line is. It's just those points. Your inputs are only the whole positive whole numbers or positive integers. Well, integers, a fraction. No, a whole number. Oh my goodness. Okay, so anyway, your integers, your positive whole numbers or your positive integers are your inputs, but you cannot have the halves or the thirds or anything. Okay, so that's, again, writing a rule. And what were we given? You were given one of the points or terms, and you were given the common difference. Well, what if instead of being given the common difference, you are given 2 terms? Kind of like when you're writing a linear equation and you're given 2 points. This is the same idea. So the common difference will be the slope between these 2 points. So to find D, I just like using the slope formula. So because it is linear, we can do that. So your common difference, or D, is going to equal, we'll just say y2 minus y1 over x2 minus x1. And these 2 terms here will give us 2 points. So we've got the point 5, negative 43. So because the input value is 5, the output is negative 43. And this one, the input is 12, the output is negative 8. So this is my x1, y1, x2, y2. And then plug them in your slope formula to find your common difference. So my y2 is negative 8 minus my y1, so I'm subtracting a negative, which makes it positive 43. And 12 minus 5, and let's look at my cheat sheet here. Okay, so that gives us 35 over 7, which equals 5. So that's our common difference. D equals 5. Well, now that we know our common difference, we can do what we did in the last example to find our first term. So we have to find the common difference, and we have to find the first term of the sequence in order to write the rule. All right, so again, I'm just going to separate this here. We're going to right here. So a sub n equals a sub 1 plus n minus 1 times d. We're going to use either one of these points. It doesn't really matter which one. So I'll just use the one with the smaller n value. So instead of a sub n, we're going to plug in negative 43. A sub 1 we don't know. The n is 5, so that's the number down here, minus 1, and our d is 5. We just found that. And now we have to solve for a sub 1. So distribute, or no, we don't have to distribute because we can just subtract. 4 times 5 is 20, plus our a sub 1 equals negative 43, subtract 20, and we get a sub 1 equals negative 63. So now I can finally write my rule, and I'm running out of room, but I'll just kind of squeeze it in here. So for problem A, let's see, a sub n equals a sub 1, which is negative 63, plus n minus 1 times the common difference, 5. Distribute now because we don't know what n is. N is now back in our equation. And we'll have 5n minus 5 plus the negative 63, combine like terms, and we get a sub n equals 5n minus 68. And that is our rule. Whew, man, that's a lot of work. But you can do it. Okay, so the next one is just like it. Again, we'll go through. I know sometimes the first time through, the examples don't make sense, so I like to show 2 examples with different numbers so that maybe the second time through you'll understand better. But I'm going to try to use some of the rube up here. I guess when I reprint this, I'm going to need to put more space in it. Okay, so we're given 2 terms in the sequence, and we need to write the rule. So those 2 terms, you can rewrite them as points, 7, 71, 16, 26. From those 2 points, we can find our common difference, and the common difference is basically the rate of change or the slope between these 2 points. So my slope or common difference, y2 is 26 minus my y1, which is 71, over 16 minus 7. So when I subtract, I'm going to get negative 45 over 4. And since that does not, or no, 9. Okay. Negative 45 over 9 divided by 9, which equals negative 5. So our common difference, d, equals negative 5. So that's going to be put into our equation, but not until we know the first term. So we have to find the first term. Again, using that formula, you're going to see that formula so many times, there's no way you can't not remember it. So a sub n equals a sub 1 plus n minus 1 times d. Again, we can use either one of these points. I'll just use the first one. So instead of a sub n, I'm going to plug in a sub 7, which is 71. My a sub 1 I do not know yet. The n was 7, so since I used 71, I'm going to use 7. That's my index. Minus 1, and then d we can now plug in is negative 5. So now again, do the math. We get 6 here times negative 5 is negative 30. So a sub 1 plus a negative 30 equals 71. Add your 30, and we get 101 is equal to our a sub 1. So the first term is 101. So now that we know our common difference and we know our first term, we can finally write our equation. So again, I'm running out of room. Sorry. Okay, so again, a sub n equals a sub 1 plus n minus 1 times d. And actually, I'm going to erase this here. I'm going to use some space down here to finish this problem. Okay, so let's plug in what we know. Well, we're writing a rule for a sub n, so the n now comes back into our equation. A sub 1 we found was 101. N, again, comes back into our equation. That's our input, kind of like x. And then our common difference is our slope, or rate of change, -5. And then simplify it. Distribute the -5, and you get 101 minus 5n plus 5. Combine like terms, and we get our rule -5n plus 106. And there we have it. So yeah, this one, these types of problems do take a little bit longer, but it's doable. It's not impossible. You just have to go through it, find one thing at a time. So we found our common difference, then we found our first term, then we plugged in the first term and the common difference to write the equation. So it's just doing those 3 steps and you get the result. Okay, last but not least, we are going to find the sum of a finite series. So notice we changed the word from sum, or from sequence, to series. So series, again, means that we're finding the sum of the arithmetic sequence. What's nice is we have a formula. We don't have to actually find all the numbers. So like in this example, if we're trying to find the number that we would get if we input 1 and then 2 and then 3 and then 4 all the way up to 22 and add them together, that would take a very long time. So mathematicians found this nice formula that we can use to find the sum. So S sub n is basically the same as, a little bit similar to this notation. Let me just show you the difference. So in this formula, n represents the upper limit. So this is our upper limit, and that is equal to n. So if we're trying to find the sum of the first 22 numbers of this sequence, or s sub 22, it's going to equal our n, which is 22 again, and then a sub 1 plus a sub n over 2. Well, I don't know what a sub 1 and a sub n are. I haven't figured those out yet. So I guess I'm going to have to do that. All right, so a sub 1, let's just do that off to the side over here. A sub 1 is what you get when you plug 1 into this rule. So remember, this is your rule that you're plugging or substituting all of the indexes into. So if I put 1 in for I, 5 minus 2 times 1 is just going to equal 3. So my a sub 1 is, so in my formula, I have a sub 1 plus a sub n. So a sub 1 is 3. My a sub n is a sub 22, so the 22nd term in the sequence, which if I plug in 22 here into my rule, I get 5 minus 44, which is going to be a negative, I can't think right now, 39. So my last term in my sequence is negative 39. So I take that number and that number, which is my first term and my last term, and add them together, and then divide by 2. So it's really just the average of the first and last term of the sequence multiplied by the number of terms. So once again, the average of the first and last terms, so you'd add the first and last term together, divide by 2 to find the average of the first and last term, times the number of terms. So now that we have all of our numbers, we can simplify this. So if I add 3 and negative 39 together, we get negative 36. Divide that by 2, and we get negative 18 times 22. And got to calculate that. Negative 396. So that's a whole lot better than finding the first term, second term, third term, fourth term, all the way up to the 22nd term and adding them all up. So the formula is only good, though, for finding the sum of a finite arithmetic sequence. So look at these rules here. Hopefully you can tell that these rules are linear in nature because they have the variable to the first power. And that's when you can actually use this formula to find the sum of a series that is linear or arithmetic. Okay, so as always, I like to do 2 examples just to make sure that you get a good understanding. So we're going to use this rule again. So that's another one that we should probably highlight. That's another very important formula that we need to know. All right, so let's figure out what we can. This is, again, our upper limit, which is equal to n. So our n is 18. We have to find, in order to plug this in the formula, we have to find the first term and the last term. So maybe off over to the side over here, I'm going to find a sub 1. So if I substitute 1 into the rule, I'm going to get 4. So a sub 1 equals 4. We're going to use that in our formula right here. And then a sub n, which again our n is 18, equals 6 times 18 minus 2. So I'm going to use my calculator to help me with that. That's going to give me 106. So a sub 18, or the 18th term in the sequence, is 106. Now that we know n is 18, our first term in our sequence is 4, the last term in our sequence is 106, and we can find our sum. So the sum of the first 18 terms, so again we have to have, this can't be infinity, so we're finding the sum of the first 18 terms, is equal to 18. Again, we're plugging 18 in for n. Take the first and the last term, add them together, so the 4 and the 106, add those together and divide by 2. So when you add them, you get 110 divided by 2 is 55. Then when you multiply the 18 times the 55, the sum of the first 18 numbers gives us 990. And there you have it. And oh man, I thought I was done. You probably thought so too. Okay, so there's that example. And again, this is what we do to find the sum of a finite. Again, it has a certain end. The upper limit is a number. It's not just going to go on forever and ever. And it's only, this formula can only be used for arithmetic sequences, which again, if you look at the rule, it's linear because your variable's to the first power. Okay, the last one, the last example is, of course, a story problem. Got to learn how to apply what we've learned in real life situations. So we have a camp counselor that's earning $300 for the first week of summer camp, and then $350 for the second week of summer camp, and $400 for the third, and so on, up to 8 weeks. So some of you are thinking, yeah, why don't we just, take 300 plus 350 and find the first 8 weeks and just add them up? Well, that's not the point. The point is to use the rule. So we're trying to find, let's see, write a rule for the amount the counselor earns for the nth week. So this is what we did in the beginning, where we were finding the nth, writing a rule for the nth term. So write a rule for the nth term. And in the information, you are given a couple of points, or the first actually the first three numbers in the sequence or series. So we can look at those numbers and figure out what the common difference is. So your common difference, if you notice it's going up by 50s, or if we subtracted 400, so if we wrote it as a list, it would be 300, 350, 400. So if I subtracted right to left, I would get 50 and 50. So our common difference, D, equals 50. The other nice thing about this is they're telling us what they earned the first week. So if this is the first week, then this is our first term in our sequence. So a sub 1, or the first term, is 300. So with the common difference in the first term, we can then write the rule for the nth term. Again, that formula, a sub n equals a sub 1 plus parentheses n minus 1 times d. All right, so let me switch up my colors here a little bit. So a sub n equals the a sub 1, which is my first term in my sequence, is 300. The n now is back in the equation. Common difference is 50. So I'm going to distribute, and I'll get 300 plus 50n minus 50, combine like terms, and rewrite it over here. A sub n will equal 50n plus 250. All right, so we satisfied part A, which said write a rule for the amount the counselor earns in the nth week of the summer. So if you put a 3 in there, or 4 in there, or 5 in there, you would figure out what they earn in those weeks. So now they want to know, how much does the counselor earn for 7 weeks of camp? The wording here I probably should revise a little bit. So I believe this is finding a total. So find the total amount that the counselor has earned in 7 weeks. Oh, I'm looking at my notes here from last year, and I'm noticing that I changed the 7 to 8. So you need to do that, which would make more sense. If they want to know the total amount that they earned in the entire summer, then you would want to use 8 for, so this is your total earned in 8 weeks. So again, change that 7 to an 8. So now we're finding the sum. And again, some of you are thinking, yeah, I could just take 300 and 350 and 400 and just add them up. But again, that's not the point. The point is to use the formula for the sum of an arithmetic sequence and practice doing those things. Because you're not always going to just have 8 weeks. You might have 10 or 12 or 52. Who knows? So the sum of the first 8 terms, or S sub 8, is going to equal the number of terms, 8, times the average of the first and last term. So the first term in the sequence was 300. The last term we would have to figure out by substituting 8 for n. So if I find a sub 8, 50 times 8 plus 250 would give me 400 plus 250, which is 650. So I'm going to put that back over in my equation. I need a little more room. All right, so that 650 now goes back in my equation. Add those up, and I'll get 950 divided by 2. So 950 divided by 2, 2 goes into 9 4 times, 2 goes into 15 7 times, and 2 goes into 10 5 times. So 475. Then multiply that out, and we get 3,800 is equal to the sum of all 8 weeks. So for the whole summer, or the 8 weeks, you earn $3,800. And that ends our notes for section 7.2. Thank you very much.